So in this video we're going to talk about how to go from a molecular formula to an empirical formula. And a molecular formula describes the actual number and ratio of atoms in a molecule. The empirical formula simplifies that and reduces the subscripts in the molecular formula down to the simplest possible ratio of atoms. So some general rules. Look at the subscripts for each of the elements in the compound and determine the greatest common factor, that is, the largest number that will divide evenly into each subscript. Once you figure out the greatest common factor for all the subscripts, divide each subscript by the greatest common factor, and you're left with the empirical formula. So our first example, let's look at sodium peroxide, Na2O2. That's our molecular formula. We have two elements and two subscripts. Each subscript is 2. The greatest common factor, so the greatest number that will divide evenly into each of these, is 2. So we divide each subscript by 2, and our empirical formula becomes Na1O1. So NaO. We're reducing all the subscripts down as far as possible while maintaining the ratio. Here the ratio is 2 to 2, which can be reduced down to 1 to 1. And notice we maintain that 1 to 1 ratio in the empirical formula. And we have C3H6, that's cyclopropane. The greatest common factor between 3 and 6 is 3. So we'll divide 3 by 3 and 6 by 3. What we get is C1H2. The ratio of 1 to 2 between carbon and hydrogen is maintained. Let's look at sugar. C6H12O6. Greatest common factor between 6, 12, and 6 is 6. Divide by 6 for each subscript. And what we get is C1H2O1. So we have a 1 to 2 to 1 ratio, 1 to 2 to 1 in the empirical formula. So notice the ratio is the same between the molecular and empirical formula, but we're reducing it, simplifying it down to the lowest numbers we can. Sodium persulfate, that's Na2S2O8. Greatest common factor is 2. So we'll divide each subscript by 2. We get NaSO4. Butyric acid, C4H8O2. Greatest common factor is 2. We'll divide each subscript by 2. We get C2H4O for the empirical formula. This one's a little different. Acetophenone is C8H8O. Now don't forget O has an invisible 1 subscript, and the greatest common factor for 8, 8, and 1 is 1. There's no larger number that will fit into all three. So if we divide each of the subscripts by 1, what you'll see is that we end up with an empirical formula that's identical to the original molecular formula. So that's a tip. If any element in the molecular formula has a subscript of 1, then the empirical formula will be identical to the molecular formula because it can't be simplified down any further. And that's because the greatest common factor for this type of molecule is 1. And dividing all the subscripts by 1 results in the same formula as the original molecular formula. Let's see that again. Carbon tetrachloride, there's a 1 for carbon. The greatest common factor is 1, and we're left with the exact same for the empirical. Oxygen gas is O2. We only have one subscript, so the largest number that can be divided into itself is itself, and we're left with just O for the empirical formula. Benzene C6 C8H6. We can divide each subscript by 6, and the empirical formula is CH. For these last two in particular, the molecular formula on the left provides a lot more information about the molecule. It tells us how many atoms of each type are in the molecule, whereas the empirical formula for oxygen, we don't know if we're talking about atomic oxygen or diatomic oxygen gas. CH is the empirical formula for many hydrocarbons, but in this case, the molecular formula indicates that we're looking specifically at benzene. So the molecular formula provides a lot more information, so it's preferable to have if possible, but the empirical formula simplifies all the subscripts down as far as possible. So let's look at some more tricky examples. We have potassium dichromate, K2Cr2O7. There is no common factor larger than 1 that will divide evenly into all of these subscripts, so the empirical formula is the same as the molecular formula. Let's compare that to potassium dithionate, K2S2O4. Here we know that the greatest common factor is 2. So our empirical formula is KSO2. Dinitrogen tetroxide, N2O4, and O2. Greatest common factor is 2, and we can divide 2 into both 2 and 4 and get 1 and 2 respectively. Sodium tartrate, C4H4 Na2O6. The more different types of atoms there are, the trickier it gets to find the greatest common factor. But here we have 2, 4, and 6. We know that the greatest common factor can't be any larger than the smallest subscript, and in that case 2 divides evenly into each subscript. The empirical formula for sodium tartrate is C2H2NaO3. Finally, water. We know that oxygen has a subscript of 1, and we know that if we have a subscript of 1, then the empirical formula is the same as the molecular formula.